Just wanted to thank you all for attending today. I also wanted to thank Rackspace for letting us use their space here. Also, thanks to Datadog for providing the food and beverage. And just a quick note, so we're handing out our NGINX t-shirts here, so feel free to grab one. If you tweet a photo of yourself at and tag NGINX, we will give you a discount to NGINX Conf 16 this year, which will be in Austin, Texas. Also, bathrooms are straight back towards the left if you guys ever need to run throughout the whole presentation or anything. And Wi-Fi information is up here on the board. Username is NGINX, password is Datadog. And let's see. So a little bit about the speakers. John Matson is a technical content developer at Datadog. And Nick is our technical solutions architect at NGINX. All right, so we'll go ahead and kick it off to John Matson in just a few.
Hi, everyone. Thank you for coming. Thanks to NGINX, Catherine and Shirley for having us, and for everyone else in the NGINX shirts here who I haven't met yet. Really excited to be here. I just moved back to Northern California after 12 years in New York, where Datadog is headquartered. And this is my first time being in San Francisco since I've moved back, so it's really great to be back. I'm happy to be here. Who am I? As I said, I'm John Matson. I do technical content at Datadog. For those of you who don't know, Datadog is a hosted monitoring service. We monitor 120 plus different applications, services, tools, what have you, operating systems, languages, you name it. DatadogHQ.com is the website if you want to check it out. And my Twitter handle is JMTSN, J Matson without any vowels. If you want to follow me, I'll be tweeting a link to these slides as soon as I can after the talk. This is a picture of me and my daughter in sunny San Francisco a few weeks ago. San Francisco, in this case, happens to be the name of a town in Mexico. And when I made this slide deck, I thought that would be sort of funny because San Francisco is not that sunny in February, but here we are, and it's like 80 degrees outside. So I guess, you can't plan everything. So this is the plan for my talk. I'm going to start off with a little motivation about why we care about monitoring, why we think metrics matter, what we think you should be paying attention to. Then I'm going to go into the sorts of metrics that you can get from open source NGINX via the stub status page, what you can get from NGINX Plus, the commercial offering, what you can get from analyzing and parsing NGINX logs, and of course, a shameless plug at the end for how Datadog can help you do some of those things. So that's the plan. This is a fairly quick talk, I think. So if you have questions at any point, there will be a Q&A afterward, but if I'm going too fast or if anything is unclear, please feel free to just stick a hand up and or interrupt me to shout out your questions, and I will address them as best I can. So quick question before we get started in earnest. How many people here, aside from those of you who work for NGINX, use NGINX actively? All right, most everybody in the room. And I'm guessing the people who wear NGINX shirts probably use NGINX quite a bit. NGINX Plus, do we have any NGINX Plus users in the house? Okay, cool. So I'll be telling you something new then. And how many of you NGINX users have some kind of monitoring in place, even if it's just like looking at the stub status page from time to time? Okay, just a handful. All right, great. And Nick, good deal. So this slide kind of encapsulates our feelings, our philosophy of monitoring. It says, if you can't read it, collecting data is cheap, but not having it when you need it is expensive. So even for a system that's really reliable like NGINX, I mean, a lot of you, as you just shown, are using NGINX and don't really monitor it. That's fine. But even for a system that's really reliable, our opinion is that you want to have all the metrics you can. If something goes wrong, you want to be able to sort of triangulate what the problem is, even if the problem isn't in a system like NGINX. The metrics that you get from NGINX might help you pinpoint where the actual issue is. Also, having metrics from all your systems can help you rule things out really quickly. So if something is going wrong, you can look at your metrics from NGINX and say, okay, we've got plenty of capacity, things are going fine, there's nothing on the NGINX side, it must be somewhere else. So in short, you never know what metrics you'll need and when you'll need them. So we advise, as we say, collect, basically monitor all the things all the time. So what do we actually mean when we talk about metrics and monitoring data? You can think of monitoring data as belonging to one of these three categories, although there are exceptions. I don't know if you all can read that in the back of the room, but the three categories are work metrics, resource metrics, and events. We're mostly going to be talking on work metrics, talking about work metrics tonight. Work metrics are metrics that pertain to the actual work that your system is doing or should be doing. So in the case of NGINX, that work is servicing requests. So you care a lot about whether it's servicing requests, at what rate, how fast is it servicing requests, and are you getting any errors? Are you getting client errors? Are you getting server errors? The next column is resource metrics. Those can be sort of the familiar resources that you think of, CPU, memory, system load, things like that. They can also be application level resources. So in the case of NGINX, you might have a finite pool of connections to work with. Same with a database. That's a resource, a finite resource. You want to keep track of how it's being utilized. Events is the third column. That is sort of a different beast. Instead of both resource metrics and work metrics are data points that stream in at regular intervals, events are discrete occurrences that happen just every so often. So the events, or the examples that we have here are code changes, alerts, scaling events, and et cetera. So you can see that a lot of things fall into that bucket. But like a new server coming online as you scale up, that's an event. Like a code deploy. That's a sort of a canonical example of an event. You want to track those. They're not necessarily going to be bellwethers of something bad happening in your infrastructure, but they can help you sort of deduce what is going on when something goes wrong. They're really helpful context to figure out what's going on. So again, we're mostly going to focus on work metrics. Work metrics are the things that you want to know about whatever the hour. So if your system stops doing work for any reason, you want to know about it. You want someone up and on it, even if it's 3 in the morning. If you're not servicing requests, if they're going really slowly, if you're seeing a lot of errors, there's something wrong, and you want to do something about it. Whereas with resource metrics, again, they're really helpful for investigating problems, but like if your CPU is really high on some machine, maybe that's a problem and maybe not. You probably don't want to be paging people and waking them up at 3 in the morning because your people are just going to get burned out and are going to disregard every alert that comes through your system. So the work metrics that we're going to be talking about mostly in terms of NGINX are throughput, requests per second, errors, any requests that result in errors, and also performance metrics for your requests, which is latency, time to process. So if you're using open source NGINX, as most of the people in this room are, it's incredibly easy to enable status monitoring. You just add this little block to your config, restart NGINX, and voila, you get this nifty little page. Here it's localhost NGINX status that gives you some very high-level metrics about connections and requests in your system. In terms of the work metrics that we were just talking about, you get throughput, essentially, because you get a count of requests, and you can do the delta between successive samplings to figure out how many new requests there have been. You can also figure out if any connections are being accepted but not handled, so they're being dropped, and that's bad. That shouldn't happen. You don't see that happen very often. The pros of this approach are that it's free. It's very easy to set up. You can do it in just a few minutes, and then you have those numbers there when you need them. The cons are that it's incomplete. You don't get the full suite of metrics that you might want, but certainly it's better than nothing. You don't get any latency measures. You don't get any insight into whether you're seeing error response codes or success response codes. You're just seeing a count of requests that increments over time. So if you're using NGINX Plus, one of the really nice features of NGINX Plus, it's a bit hard to see it here, but if you go to demo.nginx.com/status.html, you get this really nice looking status page that gives you all of the metrics that you get from open source NGINX, plus a few new metrics that are really useful if you're doing load balancing or anything like that. You get metrics from various, upstreams and server groups. It's really nice, and you just flip it on, and you have this nice visual display. And so that gives you requests, throughput, drop connections, which is a type of error, and also gives you the 400 and 500 response codes. So you can see if you're getting client errors, which you probably can't do anything about. Those just happen from time to time. But if you see a big spike in client errors, there might be something wrong. You also get 500 codes, so you get server errors, which, of course, you probably want to know about right away. Another really, really nice thing about this is you get all the metrics, not just in this pretty web page format, but also in JSON. So if you go to the same URL, demo.nginx.com/status, you can see the JSON version. I don't know where those metrics are actually coming from, but they seem to be updated. Oh, okay. So they're real for something. Okay. Anyway, it's worth checking out. You can see that there are a lot of metrics, and they're segmented very nicely so that you can figure out where everything's coming from and which groups of servers are reporting which metrics. The nice thing about JSON, of course, is that it makes these metrics super, super portable. You can, just about any external monitoring tool can ingest all those metrics and basically do whatever you want with them. The only con of this approach, the only thing that's missing is you still don't get latency metrics. A lot of people, that's fine. This is all they need. But if you really care about the request processing time, you don't get it through this approach. But definitely highly recommend checking out the demo pages here just to see what's available and see what you can get. So we've seen that you can get some good basic high-level metrics from NGINX open source. We've seen that you can get even more metrics from NGINX Plus. If you really, really want latency metrics, we think they're important. Not everybody cares a whole lot about that. Or if you're using open source NGINX and you want insight into the particular error codes or the particular requests that are being made, the way to do that is through NGINX logs. So here, it's kind of hard to see. This is just a tail of some access logs. This is a blow up here of sort of the interesting section in the middle. This is the actual request, the GET request. You can see the protocol. So one is HTTP 1.1, one is HTTP 2. You can see the response code, 200 for both of those, which is good. That means OK, of course. And the response time. So you can see in seconds, this one took 0 seconds, so maybe it was cached or something. And this took 0.015 seconds, so pretty quick. But you can actually see on a request-by-request basis what the request was, how long it took, what the response code was. So lots and lots of valuable information in the logs. They're also very, very easy to set up. There's a default logging format in NGINX. So you literally can just change one line of your config, and you're spitting out logs. I think you have to modify them a little bit to get response time. Again, it's not very hard to write a custom format, and you can just pare it down to the information that you need very, very easily. So it's super fast to set up, customizable. You can see, and Nick's going to talk about this a bit more, you can see whether the requests are, you can see the protocol of each of the individual requests. You get error codes, you get latency. All these things are good. Of course, as with anything to do with logging, there can be a low signal-to-noise ratio. You're just logging everything. You have to figure out a way to collect and parse and analyze those logs. That's not always that's not a non-trivial thing. I know there are a lot of good log solutions, log analysis solutions out there, but if you don't have one of those already, that's a non-trivial amount of overhead. But being that you can get error codes and latency metrics, which are pretty hard to get otherwise, if you're on open source NGINX, this can be a really good complement. Let's see here. So this is just a quick summary of sort of what I've already talked about. These are all of the sort of high-level metrics that come from NGINX, which ones you can get from open source NGINX, which you can get from NGINX Plus, and which you can get from the logs. So as you can see, and I didn't go into great depth about all these metrics. Some of these are resource metrics, which are more interesting for investigating problems than for detecting problems. So they're good to have. I just haven't gotten into them here for the sake of limited time. But as you can see, NGINX Plus has the best coverage. You get the most metrics that way. But if you're on open source, the logs complement the piece that you're missing. So if you can sort of justify the complication of collecting and analyzing logs, that can provide a lot of the information that you wouldn't otherwise be able to get. So as I promised, shameless plug, where Datadog fits into all of this. As I mentioned, we're a SaaS-based monitoring solution. We integrate with a lot of different tools that you're probably already using. In particular, NGINX is one of our most popular integrations. It's an agent-based integration with NGINX. You install it on your servers, and it immediately starts capturing metrics from NGINX or NGINX Plus, whichever one you're using. You can then graph those metrics. You can set alerts on those metrics. You can parse NGINX logs too. Not out of the box. It requires sort of a custom parser script. Nick's going to talk about that a little bit more, so I won't go too much into too much depth there. But the nice thing, if you can see here, you get a little NGINX dashboard out of the box. So you can see live graphs of all the metrics that are coming out of NGINX. You can see all of your servers color-coded by, I believe, throughput in this case. You can see if you're having any dropped connections, which is not good. There you can see they're green and 0. That is good. So you get all these metrics in nice, sort of pretty graphs. You can see not just a snapshot of what your metrics are at one point in time, but how they're evolving. And you can go back and view your historical metrics as well. Because we have 120 plus supported integrations at this point, you can correlate your NGINX metrics with basically anything else that's running atop, below, alongside of NGINX. So you can see your system level metrics, your application metrics, your database metrics, your load balancer metrics, correlate them, and if you have any issues, figure out what the root cause is. And we also integrate with tools like PagerDuty and Slack for communication, collaboration, issue resolution. So essentially, we try not to reinvent the wheel. If you're already using tools like Slack to communicate, you can just route your alerts through there. Pardon me. And if you have custom metrics from your internal applications, you can send those too. We support the StatsD protocol, which, has anyone ever used StatsD? All right, Kevin's nodding his head. Okay. So you can basically, whatever programming language you're using, you can basically just start firing off custom metrics and graph them, alert them as you would with any other metric. So this is my, I believe, penultimate slide. These are a couple of guides that my team has worked on. This is a 3-part series on how to monitor NGINX. And this is a series that we did called Monitoring 101, which talks about the various types of metrics that are out there, what you should be focusing on, how you should be setting up alerts, and how you should go about investigating and resolving issues. So as I may have mentioned, I'll be sharing these slides after the talk. I'll post them on my Twitter account. I'll also post them to the Meetup page. So if you want to follow any of these links afterward, you can do that without writing down the URLs right now. And so with that, that's the end of my talk. Thank you very much for listening. I'll be happy to take any questions if you have them. You can also reach out later if you'd like. Again, my Twitter handle, JMTSN, and my address, my email is john@datadoghq.com. John with an H, because we do have a John with no H, but he would probably forward it to me anyway. So again, thanks for your time. Thanks for listening. And if anybody has questions, I'd be happy to address those. So log parsing and sending metrics in general is production ready, but the NGINX log parser is not a fully supported piece of software. We do, there are some community contributed parsers that we sort of casually recommend, but it's sort of, they're not warranted essentially, right? Like you're sort of on your own to figure it out and make it work. I'm optimistic that will change at some point, but yeah, as of now, it sort of requires some customization on your end to either write or modify scripts that are out there. That said, they're pretty simple scripts. I can send you a gist after this, or you might already have it. It's not that long. Yeah.
Sure. A couple of questions. First on the NGINX Plus.
Mm-hmm.
So on a busy web server, your NGINX, however you set it up, your logs can roll really fast. Are there any performance or scaling implications on the NGINX Plus side of things, in the sense of it's monitoring, it's collecting metrics from these logs?
I might leave that to Nick.
Okay.
So basically, when you use the login subsystems to dump some information on the disk, the way it works with NGINX Plus or NGINX Open Source or basically any other system in the world, its performance is basically the same. What you can get from NGINX Plus is a set of predefined metrics, which are not the logs. Metrics provide you the aggregated data on the current state of the system. Those metrics are not written into disk. They are taken from memory and delivered into network sockets. So in that case, your disk is not used.
Was there more?
Oh, actually, yeah. The second question was on the flip side. So with the Plus, that's collecting, that's everything on the client side. I guess the second question is for the Datadog side of it. If we were sending this directly into Datadog and the volume was high, are there any requirements and so forth that Datadog puts in place so that a customer can make sure they can still see the things they need, but at the same time don't have maybe pushback?
I mean, the agent, the Datadog agent, you're asking if Datadog is able to handle a high volume of metrics coming through. Yeah, it's. I mean, we have big customers with very busy websites. The agent by default, I think, sends data every 15 seconds or 20 seconds. So, what's that? Every 19? Okay. he's been getting deep in the past few days. You can adjust that. I mean, you can send it at shorter granularity. You can send metrics at finer and finer intervals, but for the most part, that works fine for people, and that's no problem on our end. Yeah. But yeah, at those numbers, it shouldn't be any problem. I mean, we as a company, we run lots and lots of NGINX servers ourselves and use Datadog to monitor ourselves. So we eat our own dog food in that case. So if there are no more questions, I'll turn it over to Nick. But again, thanks for your time. Really enjoyed speaking with you.
All right, sounds good. So basically, what I wanted to talk about is HTTP2, and I prepared a bunch of slides and a bunch of different things for you. But let's spice it up a little bit. So there is a website here. It's called http2.nginxlab.net. Basically, it's available for you. I can see a few people here with the laptops, so you can visit it. And you can compare a couple of things here. If I refresh the site, you'll see the difference. You can try it yourself. You can try it on your phone. You can try it on your laptop. And what's happening there is we are collecting some metrics from the NGINX logs, serving a bunch of different requests coming with HTTP1 and HTTP2 protocols. And once you will be updating that site, we'll see some custom metrics in the Datadog going up. So what I'm going to do here, I'm going to leave that site, http2.nginxlab.net, here on the screen. And after a bunch of slides, we'll revisit the metrics and we'll revisit the scripts that were used in order for us to create those metrics. So while it's up, let's get to play in a few slides. About me, my name is Nick Sharding. I'm a solutions architect at NGINX, and I've worked with the web technologies since I can remember. There is going to be a bunch of different links to a lot of technical resources in the slides, and I collected all those links in the same page. I will leave that QR code and the link at the end of the slides as well, so you don't have to take pictures of every slide. It's all going to be available publicly. We are going to talk about the overview of HTTP2 protocols, about the differences between HTTP2 and HTTP1. We'll talk about a very important question of HTTP2 troubleshooting. This is something that you definitely want to get into if you really want to speed up your website and see what's how to figure out what's going on when something is definitely not right. We'll see how to configure NGINX with HTTP2 support, and basically I'll show you a few interesting demos about using it together with NGINX. So first thing is little bits of HTTP history. HTTP is right now one of the major protocols used on the internet, but it's interesting to know that the first drafts of that protocol appeared in 1991, and the version 1 was properly defined in the RFC in 1996. Shortly after, in 1999, we got a major update for HTTP with the version 1.1. What were the most significant differences between 1.0 and 1.1 is the connection handling, where with 1.1 you can set up, you can send multiple requests within the same connection to the web server. And also the system of handling the headers, there was a lot of header expansion with 1.1, with the availability of caching and a number of other extendable headers in the protocol. Basically, major performance enhancements of 1.1 compared to 1.0 were the caching and connection handling. HTTP 1.1 is currently the most popular protocol that we can see, and version 2, HTTP version 2, was only finalized was finalized in RFC only last year. It was around May last year when it went when it was properly defined. So what happened between 1999 and 2015? Definitely not nothing. So what we can see here is that there was some intermediary, and there is some intermediary protocol there called Speedy. Speedy was announced by Google, and that protocol was included in the Chrome browser, and other browsers started implementing that immediately. And the major idea for Speedy protocol was to enhance performance and get rid of the shortcomings of HTTP 1.1 protocol. Major goal is reduce page load time. Major performance enhancements were the compressed headers. In Speedy, the headers are compressed the same way as usually the data is being compressed, which is gzip compression. Flow control in the protocol allows you to send multiple objects within the same TCP connection, through the same TCP connection. And another thing that was implemented in Speedy was the server push. The server push allows the server to send objects to the client without the client requesting those objects first. Normally with HTTP 1, the client has to perform the request for the server to send any response to the client. Let's go back a little bit. So who here knows who used that? Who saw those requests and who worked with HTTP headers here? Right. That's good to know that that this is not something that we need to spend time on. So let's just go into the overview. We'll continue the overview of the HTTP2 protocol. In 2015, it was introduced as a standard, and it was majorly based on the Speedy protocol. So HTTP2 is also a binary protocol that allows you to send multiple objects within the same TCP connections. TCP connection, it allows you to create, to prioritize those multiple streams of data. It compresses the headers with a different method compared to the speedy protocol. It uses HPAC method instead of using gzip. And also it gives you the server push capability to send data from the servers to the client. It's interesting. It's a very interesting way how server push works. The server tells the client what the client should have requested, with all the request headers coming in the response. That's really fun. All right. And there is an interesting question about encryption capabilities and encryption requirement in HTTP 2. As we all know, HTTP 1 doesn't have to be encrypted. Most of the websites, they are not, technically speaking, most of the websites, they have HTTP plain text version, at least for the redirection to HTTPS. With HTTP 2, encryption is technically also not required for the client to receive content with that protocol. But no browser vendor created that capability or enabled that capability without encryption. So if your clients are actual web browsers of general public, it will not work without encryption. If your clients are something that you develop yourself, if those are some kind of apps, APIs that you want to put through that protocol, it's possible to do that without encryption. Although there is not too much downside to using an SSL certificate in many kinds of traffic. There is an interesting question how HTTP2 connection is established, and HTTP2 connection is established using one of three different methods. The first method is to use the HTTP1 upgrade header, and this is the same way of establishing that connection as you would use when you establish a WebSocket connection. Another way is another two ways are using one of the two OpenSSL extensions to negotiate protocol during the SSL negotiation phase. There is a little bit of a difference between those two methods. One of them called NPN, Next Protocol Negotiation, and the other one is called ALPN, the Application Level Protocol Negotiation. The NPN method of establishing HTTP2 connection is based on the older version of OpenSSL. It is currently supported by most web browsers, but the support for NPN protocol negotiation goes away in some of the browsers this year. So what does it mean for you? It means that you have to run your website with ALPN protocol negotiation. So why that is important is because it's important because it's available in OpenSSL 1.0.2, and OpenSSL 1.0.2 is not available in the most popular operating systems right now. Yeah, so you see the idea here. You will have to run ALPN in order to run HTTP2. ALPN can work with OpenSSL 1.0.2. OpenSSL 1.0.2 is available. If we talk about Ubuntu, it starts with 15.10 version. Most of us are going with the LTS version 14. So in April, when they release Ubuntu 16, for you to run HTTP2, a good idea would be to update to that latest version. Another thing to look at when you upgrade your servers and when you think about going with HTTP2 for your websites is to revise the optimizations that you might have already put into works in your current HTTP1 website. So one is one optimization that a lot of people are using. It's called domain sharding. Domain sharding allows you to increase the number of connections coming from the web browser to a web server by creating multiple domains for your content. Normally, a web browser is opening up to 6 connections per host. So if you spread your traffic around multiple hosts, you can have multiple connections created to the backend. With HTTP2, you have prioritization and the support of multiple streams, which allow you to run multiple streams of traffic and multiple objects within the same TCP connection. So the need of domain sharding goes away. You don't actually need to create multiple host names to serve traffic from the same servers. In some cases, if you want to geographically distribute traffic, or if you want to run some kind of different traffic from different kinds of servers, using different host names still makes sense. But not in the case of just spreading it around through multiple domain names for the sake of increasing the number of connections. That doesn't really help. Another type of optimization that is heavily used with the website optimizers, it's the image spriting. Basically, the image sprites and the next optimization, concatenating the code files, it's the idea of having the smaller objects combined into one larger object in order to be sent within the same request. So when that helps with HTTP1, the first idea is saving time on header compression, since HTTP1 doesn't compress headers. If your objects are really small, you would have to send uncompressed headers for every object. So you would save some time by combining them in one object. With HTTP2, the headers are compressed, so there is way less performance impact for using that functionality. Another thing is to use, once again, the use of multiple streams and use of the same TCP connection for multiple objects and dealing with the prioritization directly within the protocol. That helps more than giving that to the network subsystems to figure it out. The browsers are usually a little bit more smart in prioritizing the objects than a pure layer 3 networking level. So the major ideas for the optimizations, those would have to be revised for your website to continue to work properly and fast if you included those optimizations in the website already. If you haven't put any optimizations in, probably a drop-in configuration of HTTP2 will help a lot for your configuration just out of the box. So this is something that we, if we go back to our page, this is something that we can see right here. That's pretty much self-explanatory. But we can do even more. What if we add some delay to this server? So right now this server is working on 1 millisecond delay, and our network is pretty fast here. I did not expect a Rackspace network to be that fast. So since it's not that fast, well, let's add 150 milliseconds of delay on that server. Here we go. Oh, you can see that in the command line. So what we're going to do, we're going to refresh that page. And now you see the difference even better. So the idea here is that latency between your clients and between the servers affects your HTTP performance a lot. If you are not using keep alive connectivity, if you are opening HTTPS connections to your HTTP1 server, that is going to be very painful for any page that uses a lot of resources inside that page. If you are using HTTP2 connectivity, the concept of keep alive will be available and included by default. And the fact that one connection is easier to maintain for the operating system and the prioritization would be handled by layer 7 tools, it gives you better overall loading of the page. In our example, we're using 165 image tiles on the left and 165 on the right. So it is a pretty extreme example. For the pages when the number of objects is significant, the impact of this feature is also quite huge. So let's go back to our slides here. All right, so let's take a quick look at the amount of web browsers and the amount of client technologies that would support your HTTP2 website today. Well, I have a bunch of screenshots, but since we have a good internet connection, we can just go to the website itself. And to see, we can see what caniuse.com website gives us in terms of using HTTP2 protocol in the current web browsers. We can see that the majority of the web browsers with Chrome, Firefox, the latest versions of Internet Explorer, Safari, and Android Chrome, they do support HTTP2 pretty well. Let's change it to the usage relative stats to see what people really use and which browsers do really matter in this case. So the Internet Explorer 8, 9, and 10, that's not likely to change. And the market share of those browsers is going down significantly. So there is no, there is not something to worry about here unless you are working with some specific corporate customers who has to use those specific web browsers. For Chrome, the situation is really good. Most of the users are on the latest versions, which do support HTTP2 well. It is expected that Chrome will drop the support for Speedy protocol at some point, together with other browsers. If we look at iOS web browsers, the latest version of iOS supports HTTP2 well, and the old ones that doesn't work. What's interesting is to look at the Opera Mini web browser and this UC web browser, which is very popular in the Chinese market. Those two mobile web browsers utilize their own proxy layers inside their own cloud infrastructures, and the connectivity between the client and that proxy layer is optimized by that browser application software itself. So they are utilizing their own optimization layers, including changing the image sizes, reducing the page size, maybe reducing some JavaScripts, and probably reformatting the pages to that application specifics. But the backend of that proxy infrastructure is not using HTTP2, and for us as website maintainers, it doesn't really impact us very much. So we cannot really do much about the UC and Opera Mini browser because of the client optimizations that are already in place for those. If we look at the Android market, the older versions of Android devices do not support HTTP2, and obviously that market share will be going down significantly when those devices are out of basically when people are starting using new Android devices, everything is quite supported for HTTP2. So if we take this 8% and this 10% out of the picture, we'll see that we will be around 90% probability of an average user to be available to access your website through HTTP2. And this is something that you will see in your stats when you enable some monitoring on in your configuration, and when you check the logs for the users that are accessing your page with HTTP1 or HTTP2. So let's go back to our page. We can see that that we were looking at this page, and on average we see more requests coming with HTTP2 than requests coming with HTTP1. It's quite interesting. I'm really not a Datadog expert, so I'm not sure how cool this graph is. My experience with Datadog is around 10 lines of Python code, and this one one interesting graph here. But well, that shows you that it's really easy to use it. Well, let's go back to our slides. So we looked at the HTTP2 usage, and the current graph of W3 tags shows us that between 6 and 7% of the websites on the internet utilize HTTP2 technology. That number is supposed to go up. Let's help it go up by enabling HTTP2 on your website. All right, that was pretty cool, right? So let's talk about what's not cool about HTTP2. There is a bunch of downsides that we can see with this protocol. First, yes, it creates more overhead for the single connection. So one single connection is going to be taking more traffic, and it does require SSL for any realistic implementation. You might not need SSL. You might be transferring huge video files where SSL is not really required. HTTP1 optimizations that you might have included already in your website that might hurt a little bit for when you are going with HTTP2, so those have to be revised. If you are working with a huge download of the files, those optimizations, they don't really help. And also, sometimes we want to create faster websites, but maybe there is a case that we don't really care about the speed of the website. That actually happens. And there is a huge downside of HTTP2. It's not really as readable as HTTP1. So when it's not really readable, what we are going to look at is how to make it readable and how to troubleshoot the HTTP2 connections. We are able... Oh, I guess my screen resolution went away here. So what I wanted to show you is we are able to see HTTP1 speedy HTTP2 support on that website. And that is something that we can see inside an encrypted traffic within the SSL negotiation phase. So we can identify the protocol without even the need to decrypt that traffic. But we do need to decrypt the traffic. And here I will show you an example on how to do that with Wireshark. For the Wireshark to decrypt SSL correctly, we need to run it with the environment variable for SSL keylog file. And it will be writing down the session keys into that file. Don't run that in real-life production for real-life traffic for the majority of the users, because it basically will make any SSL traffic completely decrypted. But for your troubleshooting needs, you can run the browser with this environment variable, and that key file can be set in Wireshark. And once it's set in the Wireshark, you will be able to see all insides of the SSL connections coming through that web browser. It is more important to look at that protocol through the real web browsers than using some command line tools, because the web browser adds some prioritization and some real-life headers to the traffic that really need to be looked at. And Wireshark will show you those headers decrypted and completely readable. So you will see the example of HTTP1 headers within the encrypted HTTP2 traffic. Okay, so there is a bunch of different benchmarks, but because we don't have a lot of time, we won't go through the benchmarks. The website that we showed you and the one that you can access yourself, the http2.nginxlab.net, that one shows you the best benchmark of them all, is the one that you can see yourself. How to configure HTTP2 with NGINX? It's very easy. First, you need to make sure that you have the NGINX version compiled with HTTP2 support with HTTP v2 module. It's very easy to find that if your NGINX version is 199 or later, the current version is 1911 and 1912 is coming next week. So if you are using our packages, that is something that's going to be supported on your installation. Or if you compile it from source, compile it with this command line argument. Also, you have to compile it with SSL. Once you have it working, you need to specify the parameter for the listen directive to listen with SSL HTTP2. Once you have it there, you're pretty much all set. When we are looking at the NGINX logs, the logs by default provide you with the request variable, and request variable has the HTTP2 protocol version in there, along with many other variables in the logs. You can change the log format to reflect on only the required variables, or to add even more to that. Obviously, those logs can be easily parsed, and an easy way to parse those logs with Datadog is to use some Python code. Please don't take that as a reference code. That's my first try of programming in Python, and you will probably do a way better job than I did in parsing those metrics. The documentation on how to take those variables from the log files and include those in your Datadog configuration are really easy, and it's really simple to do that. But don't hesitate to ask any questions to me, to John, to the NGINX and Datadog teams if you have any questions on that. So a few links at the end of the presentation. I'm running way out of time here. So how to contribute to NGINX project? You can go to hg.nginx.org to see the current sources, to check out the sources there. Also, you can take those sources from github.com/nginx, which is a mirror of hg.nginx.org. You can find a lot of information on how to build NGINX modules, and on the internals of the NGINX works inside the wiki.nginx.org. Please subscribe to the NGINX mailing lists if you haven't subscribed to those already. Those include a lot of information on how people are currently using NGINX, the current configuration snippets from different people. This is something really, really interesting. And also, if you wish to work with NGINX Plus developer license with the advanced functionality of different features, you can take the developer license from the nginx.com website. If you wish to purchase NGINX Plus, there is a bunch of salespeople in the room right there. So if you don't want to purchase NGINX Plus, please run, or they will chase you. So all the links that I used in this talk, and even more links with the frequently asked questions for HTTP2, some including the password to the developer license and everything else, is available on that website. And you can scan the code or just go to that website directly. So at this point, I will take as many questions as you can ask. Or you can do that. Go ahead. The question was, what versions of NGINX support HTTP2? It's starting with NGINX 199, which was released probably around a couple of months ago or something like that. So it is currently fully supported within NGINX open source. The first code patches that allow HTTP2 operation were available since September. And with NGINX Plus, it is supported in the current version, NGINX Plus R8.
So the idea of how HTTP2 pushes is that the server tells the client what it should request, what it should have been requesting next, and here's the answer to the question you haven't asked yet. But does that require the programmer somehow telling NGINX what files to bundle together, or does it determine that heuristically, or how does that work?
Well, currently, server push is not something that's supported through an NGINX proxy. So although the feature is defined in the protocol and it is really cool, running that through a proxy is really a very, very different question. That it is something that we are working on, but not currently in the product.
But
if you are using, I will answer your question before you ask it. So if you are using some of your own implementations of HTTP2-based web servers, for example, something on NG HTTP2 library or something else, In that case, you can go to the reference documentation on that library that you are currently using on exactly how to implement that.
But so the stuff you were showing us on your example page, that's doing that without the server push. That were you getting those speedups even without that feature?
You are correct. This is not utilizing server push in any way. So for that page, a number of requests are coming into parallel fashion on the right. So on this page, the HTTP2 portion, 165 requests are being requested from the server at the same time, and the server is sending that through one connection. For this one, there is a sequence here. So the browser is sending those requests in a sequential manner through up to six connections open to that host. So that's why you can see the sequence going in here, and this one appearing at the same time because of the same prioritization on those pages. So let's refresh that again. Yeah, this sequence looks like my Chrome browser is randomizing that. Depending on the browser implementation, the patterns might be a little bit different, by the way. And yes, this is not server push.
This might not be quite an apples-apples comparison. So HTTP2 sounds very cool. It's fairly new to me. My question is, comparing that with WebSockets, how are they different? To me, I have some applications that are running in WebSockets because of this server push, although it's not completely just, it is client initiated. But what are the differences, and where do you see the standard of like WebSockets? Where is that going?
HTTP2 server push and WebSockets, they have different reasons and a little bit of a different use cases. In some cases, server push can replace WebSockets. For example, if you want to push all the objects inside the page before the browser has requested those, or if you want to send some notifications in some of those cases. But WebSockets give you significantly more flexibility on what to include in your JavaScript code on the client. With WebSockets, you can stream different kind of data and completely control the protocol within. With HTTP2, it gives you easier tools, but not as much flexibility as WebSocket. WebSocket protocol is not currently supported within HTTP2, by the way. So the browser will open HTTP1 connection for the WebSocket request, and it's not going to be upgraded into HTTP2. All right, so I guess there is no more questions. But anyway, I'm hanging around for some time here, and don't hesitate to ask any questions right here. And thank you for listening, and thank you for staying a little late for this meetup.